So spin quantum number simply tells you the spin of the electron, right? Since the electron is spinning, right, so it has intrinsic quantum number, intrinsic angular momentum, right? It has intrinsic angular momentum. Right. So the quantum number helps to explain, it also tells us the magnetic properties that we would not be discussing right now in this video lecture. So the spin quantum number, this quantum number was discovered by George and Samuel Gaudsmit. The name is George Uhlenbeck and Samuel Gaudsmit, right? And they proposed the presence of this fourth quantum number, which is your spin quantum number, right? Which says, like I said, that an electron spins around its axis, right? It spins around its axis like you have various planets that are revolving around the sun, right? They in addition to revolving around the sun, right, they are revolving around the sun, but they are also spinning about their own axis, right? They are spinning about their own axis, right? Spinning means they are moving like this. They are revolving also, but they are moving like this, right? So they can move in two directions. Either they will move like this or they will move like this. So these are two spin states which are represented by, similarly, like these planets. So these electrons that are revolving around this nucleus are also spinning about their own axis. That is, either they are moving like this clockwise or they are moving like this anti-clockwise. So these are two spin states which are represented by up arrow and down arrow, right? And this spin quantum number will also tell us about the magnetic properties of substances. How? Because this electron which is moving around the nucleus is like a small electromagnet, right? Micro electromagnet. And this micro electromagnet, when it is moving, right, it will form its own, since it's moving, it's acting like a magnet, right? So it has its own magnetic moment, right? So the electrons that are moving will have their own magnetic moment, right? And if there are two electrons in an orbital, both electrons that are spinning in opposite directions will have magnetic moment, right? So these two electrons, the magnetic moment due to one electron would be cancelled by the other electron, right? So the substances for which the magnetic moment is zero, like here the orbitals that have two electrons, right, and both have magnetic moment, associated magnetic moment, which are cancelling one another. So these substances are dimagnetic, right? That means they don't behave like, they don't have magnetic properties, right, because their magnetic moment is cancelled, right, by each other. So these quantum number helps to explain the magnetic properties, right? Because as I said, that the spinning electron behaves like a micromagnet, right, that have a definite magnetic moment, right? And two magnetic moments oppose and cancel each other if we have two electrons in the orbital. Thus in an atom, if all the orbitals are fully filled, right, when we say all the orbitals are fully filled, that means we have two electrons in all the orbitals, right? So magnetic moment would be zero, because magnetic moment due to one electron would be cancelled by the other. So we have net magnetic moment zero, right? And the substance is dimagnetic. That means they would be repelled by the magnetic field, right? But if the orbitals are half filled, right? So just to summarize this orbital, if it has two orbitals, two electrons, as I said, that electrons are spinning, right, about their own axis. So these electrons that are spinning about their own axis will have a magnetic moment, because an electron that is spinning behaves like an tiny electromagnet, right? Since it's spinning and it has magnetic moment, so the electrons spinning in opposite directions will have associated magnetic moments, right? And both these the magnetic moments due to both these electrons spinning in opposite directions would cancel each other, right? So net magnetic moment for fully filled orbitals that have two electrons would be zero, and these substances are called dimagnetic and would be repelled by magnetic field, right? Now other cases, if an orbital, say it has one electron, so this is also the shape of the orbital that we have understood, that we have just done here. This also has one electron. So such orbitals that are half filled, right? Because the maximum electrons that an orbital can have is 2. So the orbital that have one electron, we call these as half filled orbitals, right? So these half filled orbitals will have net magnetic moment, right? These will have net magnetic moment, right? These will have net magnetic moment and would be attracted by the magnetic field, and we call these as paramagnetic substances. So where we have half filled orbitals, those substances or those orbitals will have a net magnetic moment, right, and will be attracted by the magnetic field, right, and we call these as paramagnetics, right? These are paramagnetic substances. So we have discussed our all 4 quantum numbers. Let's just quickly understand again, just revise. This is your principal quantum numbers, right? That tells us about the energy and the size of the electron cloud, right? How size of the electron cloud? If we have various energy levels, right? How it tells us about the energy of electron? The more far away the electron is from the nucleus, higher is its energy, right? Because this nucleus is attracting electron towards itself. So higher electron has to maintain, or we need high energy to take the electron away from the nucleus, right? So it tells us about the size of the electron cloud. If we talk about s orbital of this second shell, right? We have discussed like how to write the orbitals. If this first shell has s orbital, this is denoted as 1s. S orbital of second shell would be denoted as 2s, of third shell would be denoted as 3s. So electron cloud of 3s orbital is the biggest, right, because it is far away from the nucleus and its electron cloud would be like this. For 2s, the electron cloud is smaller, it would be like this, right? So it tells us about the size of the electron cloud, and if you see this formula, right, you can relate energy to the value of n, principal quantum number, right? And the second, the value of psi, right, tells us the shapes of the orbitals and the orientation of orbitals. Shapes of the orbitals, how we constructed the shape of the orbitals using the value of psi square, we constructed these electron clouds, right, and these shapes of electron clouds are nothing but orbitals, right? So we have different orbitals s, p, d, f, depending on the different shapes of these electron clouds, right? So this is s orbital, these are p orbitals, right? Similarly we have d orbitals, right? And the number of orientation for d orbital, for s orbital we have one orientation which is given by 2l plus 1, and the value of l is spdf, right? So this is s orbital, is the value of l for s orbital is 0, right, for p 1, for d 2, for 3, right? So the value of ml would be, ml represents your orientation of orbital in 3D space, right? So 2l plus 1 would be 1. So s orbital has one orientation which is spherical. The electron cloud would be spherical. So ml for p orbital would be, 2 into 1 plus 1 is 3. That means it has 3 orientations. So these are 3 orientations: x, z axis, x axis, y axis. Orientation, we mean the probability of finding electrons in these orientations would be high, right? So similarly, d has 5 orbitals, this has 7 orbitals, right? And orbitals are nothing but orientations, these orientations. And the shapes of the orbitals, Shapes of the orbitals are nothing but these electron clouds, the shapes of these electron clouds, which is given by azimuthal quantum number 0 to, we also call it as subsidiary quantum number 0 to n minus 1, right? So 0 to, if n is equals to 3, 1, 2, so different values of n, l will represent your different shapes of the orbitals. 0 represents s, this represents p, this represents d. Right, so L is equals to 2 is d orbitals, and if you want to know the orientation of d orbitals, it is given by magnetic quantum number, right? Magnetic quantum number, like for ml is equals to, for magnetic quantum number given by 2l plus 1, right? For d it is 2 into 2 plus 1, which is 5. So this d orbital has 5 orientations in 3D space, right? Now there is one more thing that we need to do, how to explain the spectrum of atoms, the spectrum of hydrogen based on these quantum numbers, right? So the spectrum of hydrogen atom, we'll just quickly do this. And we have the fourth quantum number, spin quantum number. We said that electrons, when they are moving, right, so they have opposite spins, right? They are spinning about their own axis, so they have opposite spins, right, due to which they have intrinsic angular momentum, right? So these spinning electrons have, and this spinning quantum number will also tell us regarding the magnetic properties of substances. Like we studied earlier, that if an orbital has 2 electrons, both have magnetic moments, right, and the magnetic moment of one is cancelled by the other. So net magnetic moment is 0, that means these are dimagnetic substances, right, and would be repelled by the magnetic field, right. So next is your electron spin, right. So this was discovered by Uhlenbeck and Samuel, right, and as I said that electron spins around its own axis, right. So it's like Earth spins around its own axis, right. So besides the spin angular momentum of the electron, a vector quantity. So this is like I said it, in other words, like if electron is spinning, it has an intrinsic or its own angular momentum, right, and it has 2 orientations. The electrons which are spinning, right, they can have 2 orientation, one is clockwise, the other is anti-clockwise, right. So the spinning states, which are represented as up arrow and down arrow, these electrons are moving in clockwise and anti-clockwise direction, in opposite direction, so due to which they have their own intrinsic angular momentum, right. So we are almost done with this, right, now on the topic of these quantum numbers, right. So this is important, just you can do some practice also on these things, on these quantum numbers. You will find some calculations, little small the calculations, like if you are given the value of n, find the value of l, right, and then find the value of ml, right. All these ml value will tell you the orientation of orbital, l value will tell us the shapes of orbitals, and n will tell you the principal energy level at which electron resides, right. So just remember that the spin angular momentum of the electron can have 2 orientations, right, relative to any axis. Due to the spin, an electron can have 2 orientations. So I hope all this is clear to you, right. Thanks.